All right, so this next lesson is 11.7. We are going to add and subtract rational expressions. So again, just as a gentle reminder, our radical expressions are just things with that radical symbol. So the beginning part of our homework is nice and easy because in order to add and subtract rational expressions, they must have the same number underneath the radical sign. So since this example, number 1a, which again I'm coming from the textbook page of 811, this example has 7 underneath the square root for both of them. So really what I just need to think about, since these guys match right here, is that they're the same, so I can put them together. They're like terms. So now I'm just thinking in my head, 3 plus 8. Well, 3 plus 8 is 11. And then for the radical piece, you keep it exactly the same. Nothing changes. How I relate this to something that you might be more familiar with is if I had have written this as 3x plus 8x, you guys would have told me it was 11x, which is the same idea right here. We still have the 11, and then the radical piece is whatever we originally started with. So looking at our next example, example B, we have 9 square root of y minus the square root of y. If it helps you, you are more than welcome to put that coefficient of 1 out in front. That doesn't change the value. So now I'm just looking at 9 minus 1, which is 8. And again, the radical piece stays the same. So the square root of y. All right, example number C, I'm looking at this, 12 square root of 2 minus 4 square root of 11. 2 and 11, those aren't the same number underneath the radical, so your final answer is just 12 square root of 2 minus 4 square root of 11, because you can't combine them because, again, they don't have the same number underneath. All right, D. Now, what we need to be careful on with D is there's, first of all, 3 things that we're looking at in here, okay? And I am noticing I have a 3D underneath, a 2D underneath, and a 3D underneath. So this 2D is not like the other one. So we know that this part right here can't be combined with the other 2 pieces. But this negative 8 square root of 3D and the plus 10 square root of 3D, these 2 pieces can go together. So I'm looking at negative 8 plus 10. Well, that will give me 2. And again, the radical piece stays the same, 3D. And then since this 6 square root of 2D couldn't be combined, you just put it at the end, plus 6 square root of 2D. All right, so let's go ahead and flip the page in your textbook. So we are on 812, and we are going to do example number 2, and we're going to go all through the 4 of them, okay? So example number 1A, we have the square root of 12 plus the square root of 27. Now, this is the first time that these numbers aren't the same underneath there, and they're not simplified. So like we practiced in 11.6, the first thing I'm going to do is simplify this. So I'm going to find the biggest perfect square that goes into 12, which is 4. The square root of 4 is 2, and I'm going to leave the 3 underneath. All right, with 27, the biggest perfect square is 9, and I'm going to have 9 times 3. The square root of 9 is 3, and I leave the other 3 underneath. We had a plus sign to begin with, so I'm going to put a plus sign right there. Again, underneaths match, so now I can put them together. So 2 plus 3, that gives me 5, and we leave the radical piece as it was, square root of 3. Okay, so the difference with these ones is you actually have to simplify first. So let's look at our next one, example B. So with this 8 that I have right here, I know the biggest perfect square that goes in there is 4. Now, the square root of 4 is 2, but don't forget when that 2 comes out, it needs to multiply by the 3. So I really have 6 square root of 2 plus the biggest perfect square that goes into 45 is 9. It'd be 9 times 5. All right, so then on this one, I would have the square root of 9 is 3, and I leave the 5 underneath. Now, we have a 2 underneath and a 5 underneath. Those can't go together because they're not the same. So this guy is actually just your answer because you've simplified it as far as you can. All right, let's look at example C. All right, so to begin with, 28. The biggest perfect square that goes into 28 is 4, and then we'd have times 7, and then don't forget about your x as well. Okay, now the square root of 4 is 2. It's going to come out. Remember that 2 needs to multiply by the 5, so I have 10. And then underneath I have the 7, and since this x doesn't have an exponent of 2, 4, 6, that means it's not a perfect square because again it needs an even exponent. So I'm going to leave the x underneath. All right, then I am subtracting. Well, conveniently, we already have 7x underneath the square root, and so that already matches what I have over here, so I'm just going to rewrite this. Okay, so underneath the radical symbol, they match. So now I'm just looking at 10 minus 8, which gives me 2, and leave this 7x underneath. All right, one more example. Example D. All right, 125. Whew, that gets pretty big. So let's see. I think that 25 is our biggest perfect square that goes in there, times 5. And then we still have our b, because again, b is to the exponent of 1, so it's not a perfect square. All right, so let's see. That would simplify. Square root of 25 is 5, and we'll leave the 5b underneath. Moving over to our next one, we have 4 times 5 times b. So square root of 4 is 2. That's going to come out and multiply by this guy. So 3 times 2, that gives me 6. And again, this 5b part is left underneath. All right, and then these guys we're adding, so I'll put the plus sign in between. Our next one is subtracting. And let's see, we have 45b. So biggest perfect square that goes into 45 is 9 times 5 times b. Square root of 9 is 3 that's going to come out. So I have 3 square root of 5b. All right, what's great about this? 5b, 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 they all match. So I can put them together. So let's go ahead. 5 plus 6 is 11, but then I have to minus the 3. So 11 minus 3 gives me 8. And underneath my radical is the 5 and the b. Okay, so again, please show your work. Please, please, please. There's no way you can do this in your head. So we need to see these steps of you simplifying the radicals and then combining your like terms because the radicals match. So homework for this section, we are on page 813 and we are doing 15 through 29 odd. As a reminder, show work. You must. If there is no work, there will be no credit. Second thing, don't forget to check your answers. You can check your odd answers in the back of the book. So if you see that you get an answer wrong, I will go back and see if you can fix it before you submit your homework. If you can't fix it and you don't know what you're doing wrong, go ahead and submit it and we'll help you guys out. But please, again, show your work and check your answers.